Before we get started, I think the one thing we didn't do a round of applause is for all the organizers, Mateo and Matthew and everybody. So let's give a round of applause for everybody who's part of DevOps Days Geneva. So as I said, my name's PJ. I hail from a little town called Buffalo, New York. I started my own company a little while called DevRelate.io. How many people know what developer relations is? Wow. Okay, so we do developer and community relations as a service. And what that means is, I usually don't go this much into it, but I used to work for a lot of big companies, big startups, medium-sized startups, and at one point I worked at IBM doing what's called developer relations, which is coming to conferences like this, talking about technology, talking about what's interesting in the community, taking the feedback you give me and going back to the company, and that was great. But there were all these little tiny companies who didn't have the opportunity to do that. So now I found these companies and I help them do their thing. These are all the companies that I work with. If you want more information about any particular company, feel free to ask me. Today I'm here on behalf of Humio, which is a logging, monitoring, and observability company, which is pretty awesome. I also work with an organization called Prompt, or MH Prompt. I don't know if you're aware, but mental health is a huge issue in tech. As far as occupations go worldwide, we are like second or third in the suicide rate, depression rate, anxiety rate. We're first for ADHD. Woo, we won. But the problem that we have is a lot of people don't talk about this. It's stigmatized because, well, these are our machines and this is what we work with. This is a tool, and the main tool we work with is our brain, so the last thing we want to do is admit there's something wrong. The point of Prompt is to get speakers to come and talk at events like this, to talk about their issues with mental health, and it's very raw and it's very real. But if you are interested, please get in touch. We have speakers all around the world. We have 16 or 17 speakers now, and it's our job to get them there. You just worry about holding the event. Just feel free to send an email, and we will get that rolling. So a little bit about my favorite subject, which is me, in case you didn't catch on. I hail from a town called Buffalo, New York. How many people have heard of Buffalo, New York? How many people is that because of chicken wings? Football, American football. Yeah, you know that we suck. Okay, cool. Yeah, Buffalo, New York is a great little town. I grew up there, but I'm lucky enough to have this job that allows me to travel all around the world. I've been to 5 continents, 40-some countries. Oddly, I've been to more countries than I've been to states in the United States because nothing ever happens in the middle. Not a lot going on there. But I'm also a musician. I've been playing drums since I was 6 years old. I'm a hockey coach, or I was until my son retired. And at one point, I did let my 11-year-old daughter at the time keynote RubyConf, which was quite exciting. You can look that up online. Her talks are a little bit more exciting, charming, precocious in comparison to mine. But that's, just to let you know that there's more to me than just tech, and there's more to you than just tech, and you should share that with people. But let's get started. So we're going to talk about proactive programming. And some of this is going to seem very intuitive, and some of this is not. Some of this is going to be things that you probably already know, and some of it won't be. I like this quote from Chad Fowler because it really makes sense when you start thinking about the way things are done. A lot of times people say, okay, this is our goal, and that's all we're going to focus on is our goal. We'll worry about the goal, and we're not going to worry about what's going on right now. We'll put out the fires as they come along. Let's just worry about getting to the goal. And that's kind of exactly what proactive programming is about, paying attention to the present and not worrying about the future. Fair warning, I really like animated GIFs. I feel like in 2019, I shouldn't have to say this in a talk, but some people get very upset about animated GIFs. So there will be some. It won't be all, but there will be some. Now you know, if you don't like animated GIFs, there's a talk going on upstairs, I guess. I will also apologize, warning, I took high school French. I can ask you how to get to the bathroom. I can maybe understand you telling me how to get to the bathroom, but that's the extent of my French, and I'm sorry. So we're going to start with definitions. I think this is key in every talk. You start with the basics so that we understand the terms that we're using. Again, some will be familiar, some you're going to learn. And the first one is not actually proactive programming, it's reactive programming. Reactive programming, I'm going to screw that up a few times. Reactive programming is a declarative programming paradigm concerned with data streams and propagation of change. That's a very unclear definition. It sounds very wordy, and it was definitely written by an academic. This is the easiest way to describe this is reactive programming is the way we are used to programming. It's what we see with most of the modern programming languages, things like PHP, Ruby. I come from the Ruby world. I'm a big Ruby guy. Python. non-compiled languages, even compiled languages, are mostly reactive. We use them reactively. The data that we want to manipulate or interact with is all controlled by the flow of the program. This means we can make changes to the underlying architecture when we see changes on the outside. So we're seeing what goes on when the users come and do something, but then we're reacting to it and changing. And there's a lot of positives to that, and there's a lot of negatives to that, and we're going to outline those as we move along. The negatives are going to be pretty weighty, though. Proactive programming, this makes a little more sense, focuses on eliminating problems before they have a chance to appear. So that sounds relatively easily defined, if it's not really easy to actually execute. The idea is to eliminate problems before they become problems, which sounds so simple, right? But no, not actually at all. What we're going to focus on in this talk is the tools and techniques that you use to make this process easier. That said, in no way am I saying that proactive programming requires some sort of psychic ability where you can say, oh, I know exactly how things are going to go. Not a problem. We have this, person with ESP who sits on our team and will tell us exactly what's going to go wrong long before it ever happens. That doesn't work. If it did, we would all be a lot richer or own 95 cents a minute psychic lines where you could call and find out what you're going to do tomorrow, who you're going to fall in love with. If we had those skills, we'd use those skills. No one does. But the idea behind proactive programming is to push the concept of isolating variables that might be easy to mitigate or resolve. We'll take a look at some of these things as we move on. But for now, we know what the term means. We're kind of internalizing that, and that's a good start. Another key term that we're going to look at is the feedback loop. Since this is a DevOps conference, I'm pretty sure you're all familiar with the concept of the feedback loop. Is there anyone who's not? You can be honest. You don't have to be embarrassed. That's totally fine. Totally fine. So the way the feedback loop works is in reactive programming, you do something, the program returns something, the user inputs something, maybe the way you expected or maybe not, and you find out what that is. You use that new input to change the way you're doing things. The key here is the ability to move forward based on the feedback you've received. So feedback loop. The way we understand is that we need to do and incorporate this as a major part of proactive programming. The proactive concept kind of says that the feedback loop should happen before we even get to the user, and that's the key. That's one of the key differences. And we'll talk more about this, but we're going to focus a lot more with the tools that you can use for the feedback loop. And then our final term is observability. How many people are familiar with observability? Are y'all awake? Y'all had coffee, right? So I have to read this part. According to Rudolf Kaufmann, who coined the phrase observability, it's the measure of how well internal states of a system can be inferred from knowledge of external outputs. Clearly, this definition was not developed for programmers, but it was from an understanding of engineering of things like machines and engines, like real engineering. And I don't mean to say that what we do isn't real engineering, but engineers say what we do is not real engineering. We don't build anything concrete. There are no bridges. None of us have built a car, as far as I know. We write software. But we like to call it engineering because we like to borrow phrases from other cultures and things. For mainline engineering, for like physical engineering, Kaufman is right. He's 100% correct. But unfortunately, that definition kind of falls short when it comes to modern application development. We're looking at how the application functions, what the infrastructure does, how do our servers stand up, how many AWS instances we have spinning, how often US East goes down. This is a problem. How many of you have used AWS? How many of you have seen US East go down and lose all your instances? It's less of a problem now, but 4 or 5 years ago, I used to work at a platform as a service company in support, and I can tell you that US East went down at least once a week. Part of it, maybe not the whole thing. There was one thing they called the Amazon apocalypse, but that's a story for another time. But we'll take a look at observability as we move forward, what it means, and how to kind of get involved with it. It's going to be a very big buzzword this year, so pay attention to it. So let's get started with reactive programming. Since this is what we know, we're going to focus on this first. As I mentioned before, reactive programming is the common model. We build, we release, users do something, maybe what we expected, maybe not, and suddenly we need to iterate and rebuild and re-release. Even with the modern QA techniques that we have, things like Selenium and actually having QA teams that go and punch through the program to see what's going on, and they try to break it as best they can, the reactive model is most common. Part of this is because of startups. How many folks here work at a startup? I'm raising my hand. I don't technically work at a startup, but how many have in the past or are planning on doing so? That's cool. So if you know what a startup is like, an early stage startup is all about this thing called MVP. MVP means minimal viable product. When you say it like that, it sounds like the worst thing possible. It's kind of like saying, I want to make a peanut butter and jelly sandwich. Peanut butter and jelly sandwiches are literally my favorite thing on the earth. It is the finest of all cuisines. Trust me. I'll make you one someday. You'll understand. But when I say I want to make the minimal viable product of a peanut butter and jelly sandwiches, that means I take like 2 pieces of, I don't know, shitty Wonder Bread, because I'm from America, and I throw it on a plate, and I kind of wipe some peanut butter and wipe some jelly on there, maybe at the same time, maybe on the same piece of bread. There's no toasting involved. There's no thing. But I have made what can literally be considered a peanut butter and jelly sandwich. And part of the idea behind why startups especially want to build a minimal viable product is because they are backed by VC capital. VC capital is venture capital, which means that they get money from someone who says, we think your idea is good, go make it, and hopefully we'll make money off of you. It's all a big gambling thing, and maybe it's a great business model, maybe it's modern snake oil. I'm not the person to determine that, only time will tell. But the idea is they have to build something fast. There's not a lot of time, so they want to build the minimal viable product and get to their goal quickly. If you remember that quote from Chad Fowler, we want to focus on the idea of not getting to the goal, but focusing on the present to make good software. Reactive programming's speed is kind of the interesting factor here. It leads to another very Silicon Valley startup concept, which is called pivoting. How many people know what pivoting is? All right, so maybe I should have explained more terms before I got started. So the idea is, if we build something, say it's an interactive game, some sort of game that you can play on the web. I don't know a good example, but you build a game, and people are okay with the game. They're like, yeah, it's cool, it works, it functions, whatever. But what people seem to really enjoy is the chat functionality, which is not really why you built the game, but that's the part that the users are using the most. Does anyone know a company where this happened? I'll give you a hint. You use it probably every day. It's called Slack. Slack was a video game. It was a terrible, terrible video game. But the chat functionality, my goodness, it was amazing. So Slack pivoted. They said, okay, well, we can't make money off this video game because it's garbage. But what we can do is create a chat, a browser-based chat thing, and then they built, an app that you can put on pretty much any computer, and now it annoys us constantly with all the crap that it does and notifications that it gives you. And some people get this, actually put it on their phones. That's madness. I don't need that kind of stress in my life. But the idea was this was a company with a specific vision. The question was raised on how that vision was executed, but also on how the end users and the community distort this vision through their own lens. So they built this game, and they released it to the community, and the community used it in a way they totally didn't expect. It was shocking. So they pivoted, and they changed. They reacted to the input. This is how reactive programming basically works. It was necessary to adjust, change, and in this case, completely abandon all the parts of the vision that they had laid out initially. Slack is still an extremely successful company. So I don't want to give you the idea that pivoting is wrong or pivoting is bad, but sometimes that's exactly what happens. There's other examples. Twitter was originally based on the idea that you would be able to tell your friends where you were so you could meet up for pizza or beers. Great idea. Now it's used for bad political discourse and harassing people online. And don't get me wrong, I love Twitter. I'm on Twitter every day. My wife gets very mad at me for the amount of time that I spend on Twitter and the things that I say because I am kind of a Twitter jerk. I don't harass people. I do say things politically sometimes, but most of my Twitter feed consists of albums of the day and stupid things that I think of like, hey, I just went to a really cool airport bathroom. Check out this picture. Feel free to follow me on Twitter. Feel free to tweet pictures. My handle is a splenic. It's actually a medical condition. We can talk about that later. I don't have a spleen. That was the short story. I'll tell you the long one later. But back to reactive programming. In reactive development, you solve problems as they arise. I think we've made that pretty clear. This can spark creativity, and it kind of spawns flexibility amongst the people on the team, which is awesome. You can focus on progress rather than optimizing for millions of users and security threats that aren't there yet. You're not coding for the things you don't know. You're only coding for the things that you've gotten feedback directly When issues come up, you're expected to have some sleepless nights. That's kind of the negative thing. When we use kind of the modern concept of DevOps and especially the specific thing that's grown, which is SREs. How many people know what SREs are? Site reliability engineers. Fun fact, I have to look that up almost every time. I'm like, what the hell is an SRE? It sounds like a purchasing arrangement. But we now have SREs, and in reactive programming, SREs are super important because their job is to make sure everything stands up, even when the users have decided that they're not going to let it. So there's also there's a whole slew of support roles and other functions, but this created the whole common idea of being on call. Pager duty, which some young people might not remember, actually used to involve having a pager on your hip, where someone could annoyingly call you and wake you up in the middle of the night so that you could deal with the fact that a server went down. Even the company PagerDuty is based on that concept, even though people don't have pagers anymore. But these whole things, they've proliferated. They've created a whole new industry just for the fact that we were programming reactively and not focusing on how to deal with stability in our applications. And this is where the problems start to come in. The problem with reactive programming is that most of the control over the development is now far outside the software development or DevOps team. For a simple bit of code with a few architectural needs, the user-driven approach of proactive programming totally works. You have a good chance of succeeding. A fairly verbose user with a good vision on how to really solve their own problems can easily articulate the interface, figure out how it works, and get the data required or the output that they're looking for, leaving the programmers to fill in the blanks. This works so long as the bulk of the programming is primarily business related. So if you have one little thing that your program does, that your application does, great, this will work. It's, however, a slow process, and the resulting code is super disorganized, and a lot of times it's very redundant, which I mentioned I come from Ruby. We are very against redundancy. The whole concept of dry, don't repeat yourself, is key to being a Ruby programmer. So obviously, reactive programming is not the greatest paradigm. So this also seems to take that speed and flexibility of being able to build kind of away from reactive programming a little bit. One of the big benefits is that, it's flexible and it's fast. Some might say it's agile. But that's not really the case if you're constantly having to build things. You're constantly dealing with code debt because you've built things that aren't used, or built features that no one actually looks at, or built a feature that isn't so strong that everyone is using. The user's needs tend to completely outstrip our ability to be able to code and keep the code up to date. So we're always playing catch up. We're always trying to find something that works. We're always losing customers. And that's when the people with those C titles, with the fancy suits, no offense to any, I know there's a couple people wearing ties over here, no offense to you guys. But it's kind of part of the problem. If you're losing users, you're probably losing sales. You're probably losing people before they even get into the system, which is definitely a huge negative. And that's definitely not what the people who want to make the money want to hear. Definitely not the venture capitalists backing your startup. What happens then is what I like to call the slow, painful death. I have worked at companies that have gone through slow, painful deaths. Some of them are still around, but I would say they are limping. I just spilled water all over myself because I'm talented. They're limping along. They're trying to find their way in an industry that they no longer understand. They have a product that doesn't meet the vision or needs of the current consumer market. And they're still reactively programming because now they're so far behind, they're never going to catch up. And that's true of companies that I've worked for, big and small. So it's not a super unusual story. Startups are brittle to begin with. They're very fragile. In order to survive, you need to be resilient, and your product needs to be resilient. You need to build on mistakes. I mean, even very large corporations are kind of surviving on the fact that they have something so old that they're able to keep moving forward, but they're moving forward at a glacial pace. The old glaciers, the ones that stayed frozen, not the ones today. So, I mean, very few of these places, even the big corporations, are surviving without a lot of help. And when I say big corporations, I'm talking your Facebooks, your Googles, your Microsofts, and even Facebook, if you look at it, is starting to have some failure issues. So let's be honest, that's a list of 4 companies that are surviving using reactive programming techniques. So probably not the best way to do it. But reactive programming has been popular for decades. It's mostly because it's an alternative for the failings of big, slow, long-running projects. Nobody wants a long project. No one wants to have sprints that last months. Everyone wants to be fast. They want to use the DevOps techniques. They want to deploy every day or 5 times a day. I was at a talk at a conference a little while ago. Someone was there from the company Etsy. Do you know Etsy? Etsy is like people make shitty crafts and sell them online. It's kind of a weird company. It's like, oh, look, I knitted a scarf. Oh, my grandma knits scarves. Yeah, but I'm selling mine for $250. Okay, well, you're crazy. But anyway, I digress. Etsy deploys 25 times a day, at least a minimum of 25 times a day. That's crazy. Can you imagine the amount of like continuous integration and continuous deployment tooling they have to be able to deploy that many times a day? But it's all built on the whole idea that they want to avoid project bloat. They want to make sure that they can get things faster out to the market the way they need it. And to be honest, probably 25 times a day, most of those changes are probably barely noticeable to an end user. So as the users come in and we move with reactive programming, things start to vary unreasonably off course. Timescales were so long back in the day that I worked at a company when I was first starting out where we would code something and it wouldn't get deployed for 3 months. 3 months. Can you imagine that today? It's madness. So we were and we were still reactively programmed, but imagine that you came to me and said, I need this feature. I need users to be able to add a photo. This is something that's very simple. And so I code it up, and then 3 months later you get it. Chances are, somewhere in that 3 months, you've left my company. You've gone and found another application that does something very similar, and you've changed things because reactive programming isn't as fast as we want it to be. It works in theory in the same way that the agile workflow works in theory, in the same way that communism works in theory. When the rubber meets the road, things start to change rapidly, and that change will determine whether a development team is organized enough to move with the times or if they get left behind. So that's reactive programming. Let's move on to proactive programming. Again, I need to reiterate that proactive programming is not an all-seeing, all-knowing mastermind. It's not hiring someone who knows everything about everything so that they can make sure that every problem ever is taken care of before it happens. There are no psychics. There are no ways to see the way users are going to use things 100%, but there are ways to mitigate. And if you are a psychic, go get a gig at a company that does proactive programming. You'll make $1 million, and you can totally send me some residuals, like 1 or 2%. I'm fine with that. So being proactive with programming or anything else just means that there's a considerable amount of work done first to establish a base before handling the user issues. The initial code doesn't solve problems, but it sets up the organization necessary to do that in the future. This doesn't mean you're giving up the flexibility or the iterative nature of reactive development or reactive programming completely. What it does mean is that you will need to build a toolkit to plug holes and patch leaks before they happen. So to use kind of another analogy, think of proactive programming as building a house. When you build a house, the first thing you want is a very strong foundation. You want something solid, something that's not going to get blown away in the wind, or if it snows, it's not going to shift on the ground. You're not going to build in a swamp where things are going to sink constantly. You want a strong foundation. That's what proactive programming really is. Regardless of what happens as things progress, the house is going to stand and be safe because you've built it on something that can't be shaken. Theoretically. I've never built a house. Full disclosure. In the case of reactive programming, we've built our house on sticks. They might not even be good sticks. They might be crappy sticks that we found on the ground. But it's flexible, and we did it fast, and it's great, and it functions as a house. We have our minimal viable house. Awesome. But it's not that sturdy, and it's only a matter of time before a big wind comes and blows it over. The best analogy I have for this is how many of you as kids built like a pillow fort or a blanket fort? You know, you took the couch cushions and you hid inside and it was awesome, and you know, Fort Awesome was made. That's kind of what reactive programming is, except you're saying that a family of 4 is going to live in this thing. The idea is with proactive programming, you're building a mansion and you want it to be solid and stable so that you can live in it for the rest of your life. Being proactive means that we're expecting the rain and the wind and the earthquake at some point in time. We may not know when, but we know it's going to happen. So we prepare. We put in some nice double-paned windows, some nice Spanish tiles on the roof because they're very solid. Those are like basically the 2 terms that I know about building houses. Double-paned windows are very important. In proactive development, you solve matters before they become an issue. You generally spend a lot more time on optimizations. For example, improve security, caching everything so that you can have a speedier user experience. There's two things there. A, if you're developing an application and security is not your first concern, you've already made a huge mistake. I was at a conference a little while ago, and someone was like, well, you talk about PHP, which I do sometimes. I'm not mean. But PHP is so insecure, and Ruby's so insecure. And I'm like, no. They're like, what do you mean no? What about all these different things that come up, and you see like Heartbleed and all this stuff? And it's like, okay, understand this. If you don't build applications with a focus on security, you are screwing yourself 100% all of the time. And I mean, there's lots of examples of this out there. Facebook, when it got hacked 2 years ago, do you know what they found out? 90% of users' passwords were held in a plain text file, like plain text. No salt, no change, no manipulation. It was in no way encrypted. You could just go and see that your password was password123, which is pretty much everyone's grandma's password on Facebook. And people were like, wow, how could they not think of that? This is a giant company. How could they not think of that? Because they had no focus on security. With things like caching, you focus on speed. How many people know the speed that it takes for someone to leave an application, mobile or web, if it's not reacting fast enough? Do you know what it is? 4 seconds. If I go to a website on my computer, it's even less than that. It's 2 seconds. If I'm on a machine, 2 seconds. If it doesn't load in 2 seconds, I'm like, what the hell's going on here? I'm going to try to reload it. I'll wait another 2 to 4 seconds. If it doesn't load the third time, I'm finding another product. I'm moving along. So if you're not focusing on that, there's already a problem. So speed and flexibility. The reason why I bring up that 2 seconds is because we as programmers often think of things in milliseconds. We're like, that took 0.07 milliseconds. It was forever. Your users don't care. And if we're not building applications for users, I don't really know what you're building applications for. So you'll hear a lot of different terms that are thrown around when it comes to proactive programming. We're trying to develop these more stable things, and yet oddly one of the key terms is chaos engineering. We'll talk more about that later. Observability, which we mentioned before. And the whole idea is making this schema shift amongst your team to change and understand what it's like to be proactive. So if you're going to go back to work on Monday, it's Friday, right? I have no idea. I'm so jet lagged. If you're going to go back to work on Monday and be like, yo, I saw this dude, PJ. He seemed like a really nice guy. He wore an awesome hat. He's from Buffalo, New York, so clearly he knows what he's talking about. He talked about this thing called proactive programming. I think we should do it. First of all, that's never how this works. I understand that. I've been doing this a while. Secondly, thank you for the promotional items. I appreciate being talked up at other people's work. Thirdly, the amount of work required to switch from reactive to proactive programming is not simple. You have to have a different understanding. You have to start doing things. And a lot of times you have to do it incrementally. You can definitely not walk into work and go, yo, we're going to start chaos engineering today. And your boss is going to go like, yo, you can try that at home. You are done here. But just keep these things in mind. Like, it's kind of like when everyone was like, yo, waterfall is the best. I love waterfall. Are people old enough to know what waterfall development is here? I know there's a lot of young people out there. Yeah, so people used to believe that that was the best possible model. There was no way it would change. And for years, it did not. And then all of a sudden, Agile came along, and everyone was like, yo, Agile is the best. And then DevOps came along, and they're like, wait a minute. It's like we have an add-on to Agile, and it actually works this time. And it does, but nothing's perfect. When it comes to proactive engineering, the focus is on being safe and secure. And this is where I'm not talking about security in the building, encrypting things. I'm talking about security and making sure you have stability. You want to make sure everything's like as secure as possible before putting things out into the world. This means you have a tight feedback loop. Feedback loops range from a lot of things. There's end user feedback, but in proactive programming, that's like the last piece. There's QA teams. There's things like continuous integration and continuous deployment to guarantee things work before they actually get out into production. We'll take a look at some of those specific tools in a few minutes. And keep in mind, as we look at the tools, the most important tool is the people you have executing the vision. None of this works if the human factor is made irrelevant, both in users and the people on your team. If you have a toxic environment, these things will not work. The key drawback to proactive development is it will take more time in the initial stages. So if you're still stretching your goals, you're still trying to get to that minimal viable product, It's going to take a little longer, and you might have to explain that to the people that are paying the money. Things can be fast and flexible, or sturdy and secure. Pick one and decide what works best for your organization. Chances are security is on the top of that list, so proactive will be a much bigger benefit. So let's talk a little bit about the feedback loop. As I mentioned before, we know what the feedback loop is, and it's a key to what we do. We have to be able to get input, just like our applications have to get input in order to produce output. It informs us and allows us to make adjustments and learn from the behaviors of our users. So this is kind of a behavior-driven development concept. And that's not just users that are doing it right now, but users past and present. You have to take into account what everyone was doing before you got to the point where you are now, develop for the now as well, and move forward towards the goal. But feedback definitely requires tools, and tools have to be human usable. I know that sounds like it's ridiculous, but a lot of times they're not. You could easily start using, doing things like observability by having someone whose job it is to go into your servers and tail the logs. How many people have tailed a log before? How many people found that exciting? Okay, we need to talk. You might need professional help. But it's okay, because, we don't want our modern star to shine too brightly here and be like, yeah, we're so great at making tools. We're application developers. Let's focus on the fact that humans have literally been building tools since before we were called humans. Building tools is what we do. We want to make things easier for our lives. This is why we have stuff like spoons and forks and cars and wheels and, hats, because some of us are bald and we have to protect our head from the sun. This is why we invent things, to make our lives easier. I could go all the way into tool making and anthropology and the Australopithecines, but that's a talk for another time. Some of the modern tools we use, they include things from monitoring, continuous integration, continuous delivery, QA tools like Selenium, and all of these things continue to grow as we move forward with our feedback loops. They're getting better because we need them to be better. Another piece of that puzzle, another tool, is this concept of chaos engineering. And if you've never heard of chaos engineering, here's a quick primer. Or I could have the same slide twice. That's interesting. So chaos engineering. How many people know what chaos engineering is? Do you know where it came from? So there's this little tiny company out in California that they wanted people to get DVDs in the mail. And then they realized they could stream it. And so they started this thing called Netflix. Least clever name in all of Silicon Valley. The idea was, a few people would probably be into this. I seriously believe that Netflix never expected to be quite as huge as they are. And good for them. I mean, they built something that people really wanted. They wanted to give the ability to watch Friends so many times that they're going to spend an extra $1 million to keep the rights to do it, even though Friends, I don't know if anybody here knows this, Friends is not the #1 show on Netflix. I'm filled with completely shit facts, by the way. Friends is not the #1 show. The Office, the US version of The Office, is the #1 by over 2 million users. Friends is like third, which is odd. But they decided they needed to make sure, they needed to be proactive and make sure that their systems were running perfectly. So they created this concept of chaos engineering. And it's spread to many organizations since. There's even startups that focus on doing chaos engineering as a service, which is an awesome idea because a lot of us don't know how to do it. But what does this really provide? What does this help with? So let's say half your instances in AWS suddenly fail. Half. And you're Netflix. Meaning that basically the entire west coast of the US cannot watch Friends. Sad. I know. Try to. I'm sure we could get Kleenex or something. Control your tears. I say that. I hate the show Friends, full disclosure. Anyway, what do? How do you know how to react? Is there still enough, are there still enough resources to stay up and keep working? Are people still getting what they need? That's just one example. Let's say there's a DDoS attack. Your site's hit. Everything goes down. How well does your system perform? Does your application remain available to the most users, or is there a complete crash? This is what chaos engineering is all about. You're trying to know how things will get handled, not only by the application, but by your team of engineers, your support team, And it's key to understanding where the flaws and strengths in your applications might be. Now, here's the key thing with chaos engineering. A, you are not supposed to know when it's going to happen. If you know, you'll be prepared. It's like me saying there's going to be a fire drill in 5 minutes, but pretend like it's a fire, like a real fire. Like act like it's real. Just play along. That never works. The other thing is they do it in production. Netflix literally took down half their instances in production just to see how it would react, just to see what would happen. It wasn't a sandbox or a trial. It wasn't an attempt to see what might happen. They literally took their own servers down. Half of them, 50%. That's tons. They committed a DDoS attack on themselves, where they had a team of engineers that was attacking the production environment while the other engineers were going, what the hell is happening? What am I supposed to do? That's chaos engineering. And it's always done in production, or else you don't learn from it. The next key feature in this kind of proactive toolkit and feedback loop is observability. And I've said that word a few times. I'm here with Humio. They love owls. I don't know if you caught they're really into these owls. If you send me an email, I can get them to send you like a little plushy owl that says weird things about logging on the tag. It's pretty cool. We just got them, so I don't have any with me. But observability is kind of the direct feedback from your application, from the infrastructure, the application logs, any other system that it touches to let you know how everything is functioning, what's going on a day-to-day basis. And you do that from the dev environment, the sandbox environment, the production environment. You want to monitor everything and see what's going on. There was a time when people would write code with no tests, control your shock, no QA whatsoever, and deploy directly into production. No sandbox, no testing environment, nothing. They would just write it. Sometimes live on the server, they would write it. I've committed these crimes. But that time has passed. We are theoretically better than that now. Luckily, though, we have great tools. Like Humio is a great tool for observability. They built a thing so you can actually look at all of your logs across the board, control what everybody's seeing so the devs can see the application logs, the DevOps teams can see the infrastructure logs. All of it happens in real time. Watch out, and I put that in quotes. Watch out for the term real time. Everyone says real time. And you look at things like Elastic and the Elastic Stack, and they're like, in real time, after 4 or 5 minutes of processing. Humio luckily has ingest rates of less than a second, so they're pretty cool. But the idea is to see everything end-to-end in real time. But that's not the only tool. You know, there's things out there like, unfortunately, I wrote this part of the talk slightly before the news yesterday. So there's great things like Travis CI and Circle CI. If you don't know what I'm talking about with Travis, go look on Twitter. It's very sad. There's things like Go CD for continuous deployment. It is not written in the Go language. It's just they happen to get named around the same time. But all these things let you know what hiccups can occur before anything hits production. That is so proactive. Your users might never know. It's so brilliant. And all of this helps complete that feedback loop, that understanding, mitigating problems before they get out into the world. But let's look a little further into observability. So monitoring methods and tools are now more sophisticated, more widely adopted to handle the increasingly distributed and complex systems. You know, back when I first started doing development, it was very easy to literally write a program in HTML and CSS. Your form was written in a little piece of PHP, and you could just put that file on an IIS server. IIS, International Space Station. No, IIS server, Windows server, that could be on like a Dell box with 40 gig hard drive and like, I don't know, 4 megs of RAM. They were such crappy things. And put that in a closet and you would be perfectly fine. That was a perfectly viable web application 20 years ago. Nowadays, things are a little bit more complex. You have to collect metrics. You have to understand things like SEO, which is, I don't know, dark magic as far as I'm concerned. But, you know, because of that, we need to have a more broad understanding, a broader look into our system. So for the modern tech world, we need to redefine observability. We had that definition from engineering earlier from Rudolf Kellman. For us, observability is the ability for teams to view information and investigate further how a given system is performing in real time, allowing for adjustment and fixes in order to create better systems and identify threats in any complex computing environment. If you don't think you are using a complex computing environment, there's an easy way to find out. How many of you are using Docker, Kubernetes, cloud? you are using a complex computing environment. It is not on one machine. It's not simple. It's not really that straightforward to the naked eye. But it is the way that we do things in the modern world. Real time is critical when it comes to proactive application development and monitoring. And this, I'm talking real time, as much as we can get it. So most tools focus on like digesting information, kicking it back after a certain period of time. This may be ideal for a lot of teams. Let's be honest, most of our applications are not so mission critical that you have to be concerned. And there's a reason why I say that. You're able to deploy multiple times a day. Sometimes the system goes down. We're trying to do that 9.9 thing where we're 99.99% uptime. That's how most of our SLAs are written. And that's cool. So we need feedback nearly instantaneously. But the reason why I say we're not mission critical is for one important reason. We're not saving lives for the most part. I'm going to tell a little story here. I used to work at an alarm dispatch company. And I thought, this isn't a big deal. Most of the time, we're not saving lives. These are just people that come in and their hands are filled with grocery bags and they don't hit the button fast enough to turn it off. And I believed that. I was like, all right, this is a job. You know, I was like 20 at the time. So it was like a million years ago. And I was thinking, you know, why everyone says, oh, this is mission critical. We have to be on these alarms as fast as possible. And it didn't really dawn on me until I got an alarm from a bank. And it was something that, you know, banks and alarm companies talk to each other every day. So got an alarm. It happens. These things go off on accident. Sometimes people pull the last dollar bill out of the slot, and that causes the alarm to go off for a holdup. And you call and you say, all right, what's the password? And this lady goes, it's 11111111. Don't send the police. They're going to kill me. And hung up the phone. And this is when I began to understand exactly what mission critical meant. Most of the applications we build today do not save lives. They're important to us, and they're important for varying reasons. And we try to innovate and make new things that are exciting. We're trying to make the world a better place, but we're not saving lives. So keep in mind, when your website goes down, it's not as big a deal as you think. But we have tools to make it better so that you can make sure that doesn't happen. If you are building something that is mission critical, that is saving lives, I'm sorry if I pooped on your parade. But the idea here is we want the full picture. We want to be able to build things that work. We want our end users to be happy, because happiness is really what's important. Ultimately, some of these things can result in outdated observability for just parts of the system. So if you're monitoring things and you still have people that are tailing the logs directly, going on the server and looking directly at things, that's fine, but you're missing like what's going on in the application, or you're missing what's going on with the infrastructure. If you go on a server and you're looking at the application logs, you don't understand what that server is actually doing. What's the CPU? What's the flop? What exactly is being taken up? Are disks spinning out of control? We don't know. And I say that in a physical way, but it works the same way with cloud computing. Instances use the same terminology. So removing the obstacles kind of empowers users and teams to quickly and easily query, analyze, and visualize all of their data instantly. And again, instantly. Data-driven observability is the key, because that means you can leverage all of your log data and all the real-time streaming capabilities for querying and dashboards, and the power the system of live visibility gives your engineers, not just operations, not just ops-minded people like DevOps folks, but everyone actually on the team. Observability is key, and I apparently lost my presenter notes, so I'm going to just go, because I know what I wanted to say. Observability is key to see the vast array of your system. You can see absolutely every part of it, but if you're not looking at it, or you're not actively looking at it, it doesn't offer a whole lot of value. It's kind of the idea of missing the forest for the trees. So, you know, you're seeing one tree, but you don't realize the fact that you're in an entire forest of trees. Chances are none of you are using one server anymore. Chances are you're using a large, extremely scalable cloud setup, and that's awesome. But you have to look at all parts of that all the time. Or there has to be someone who's looking at each individual part so that as a team they can come together and see what's going on. From a tooling perspective, this requires handling large data volumes efficiently and executing ingest and search with sub-second latency. And it sounds like a real simple thing, but observability is so much more than just the tools. So making systems better, wow, okay, so I see what happened. Making systems better is the goal of observability, and the more we know, the more we're able to approve and ingest. So let's kind of wrap this up. The choice here is up to you and your team. You can be reactive and be flexible. You can get to that minimal viable product. You can do all that, but it's at the cost of stability. You can take a little more time, build something that's a little more sturdy, a little more secure, and mitigate the risks. And that's good too. What's right for your team is what's important. I'm here to tell you what proactive programming is. I'm not here to tell you you have to do it. Everyone has to go to their team and say, all right, listen, what works for us? What is working? But keep in mind, think about the now, think about your goals at the same time. That's the key. Observability is the largest tool of the feedback loop. So you need this to create a proactive environment. Combine that with chaos engineering, which resides in something that I like to call the observability tool belt. I don't actually own a tool belt, but I feel like if I did, it'd have cool stuff in it. But you want to mitigate and eliminate issues before they become insurmountable obstacles, aka problems. Again, remember, tools are great, but they need to be usable and valuable to the humans who are interacting with them. Remember not to get too caught up in the tooling. Don't spend so much time deciding or becoming dedicated to a specific tool. Find a simple thing, not always the best or the biggest or the longest running or the company that's been around, but find the simplest thing that helps you to see into your systems and become proactive. Live system observability is all about this data-driven, iterative process. For teams, that improves the overall health and resiliency of their systems. The application, the infrastructure, everything that goes along with it, and the user experience. Everything has to come together to work. So that's kind of the talk. I want to say one more thing before I finish. As I mentioned to Mateo, we just launched DevOps Days Buffalo. So if you're really into this DevOps Days concept, and you also like shitty football and chicken wings, they might be called buffalo wings here, but they're called chicken wings where I'm from because it's buffalo, and it would be like calling French fries. But anyway, we're also doing DevOps Days. It's in September. The CFP is open. You can find all the information at this link, or you can go to DevOpsDays.org and just look at events. There's tons of DevOps Days. It's such a great community. And you all seem to be having such a good time here, and I'm so happy that it's in Geneva. It's such a lovely place, and I'm really glad that I got to come here. So explore more about the DevOps community. There's lots of people talking about lots of different things, and I hope you enjoy the talk. Thank you very much.
Thank you very much, PJ.